so many super interested in Google Play services. Yeah. Magnus must be super proud there's so many people interested in Play services. Yeah. Play services rocks, right? I don't have the air cannon, sorry, so I'm not throwing t-shirts like crazy, but that's his man's job. So yeah, I guess we can have a head start of a couple minutes. So, yeah. So, hidden treasures within Google Play services. Do you like the sound of that? I do. So Google Play services. Google Play services has become one hell of a library. Google now has been moving a lot of stuff from the Android framework inside the Google Play Services library. You can use it to do a lot of stuff to access all the Google APIs, and that's why they're called the Google Play Services. But also some stuff that used to be in the Android framework, like for example location, now has been moved inside the Google Play Services. And why is that a good thing for us? Well, it is good because it allows you developers to provide the same experience no matter the version of Android their devices are running. But as I said, it is a huge library. It features like more than 17 macro categories of APIs, and it has thousands and thousands of methods. So it's huge. I only have 20 minutes to talk to you about Google Play Services, so I can't go through all of it. I just want to talk to you about some cool features, like few liners you can add to your code and increase the capabilities of your applications. So yeah, I call these like hidden treasures. Sometimes the developers don't know about these very cool small features you can add, but in just a snap you can add them. Let's start with this. A lot of developers have been complaining about the 65K methods dex limit. They say, oh no, the Google Play Services library is huge, it's making my compiling blow up because I can't compile more because too many methods. So they invented the selectively compiling APIs possibility. So basically, let's say for example, you just need maps and wearables and analytics for your app, and you don't care about all the other stuff inside the Google Play Services. You just add these lines to your Gradle file, and you're good to go. You don't need to have the whole library. And that has the advantage that avoids the dex limit, and also it shrinks down the size of your APK file. So even your users will be much more happy because the size of the app is smaller. So if they have a low-end device, it's a good thing. Okay, so let's start with the hidden treasures, and let's talk about location. Everyone is doing location of their device, right? But there are a few ways to achieve the same result. For example, let's say we want to retrieve the last known location of our user. A lot of developers do this. So they use the Fuse Location API, which is contained in the Google Play Services. They create a location request, passing this location request to location updates, create a location listener for listen for these updates, and when they finally get the location, they save it, let's say, for example, with shared preferences, and then they can retrieve it later, again, from shared preferences or whatever. But you know there is a really much faster way of doing this. You only need one line of code. You just need to use the getLastLocation method. It's that damn easy. Let's have a look. So we are in the unconnected callback in our activity, and we use this line. We use the Fuse Location API provided inside the location services, get the last location, passing the Google API client, and then we have the location. And that's it. Easy, isn't it? The only thing, the only caveat here, is that you need to check if the provided location is null, because you're attaching to the Fuse Location provider, which is an overall provider of your device. So if another app has connected to location, or in general the Google Play Services have connected to Google Play to the location service before, you access that location. But let's say, for example, your user just opened up his phone and started your app. Maybe he didn't have the time to connect and then get the last known location, so you better check if it is now. But it's a really, it basically never happens. But it's good to keep it in mind. Okay, from location, let's move to places. Places is a really cool API. It has been there for a while in the Google APIs, but it's fairly new in Android. It is really cool because you can have your app understand where the user is, and so probably you can understand what they're doing. So let's say we want to understand the current place of our user. Where, like, is he in a restaurant, or where is the user? We can use, again, a one-liner, the getCurrentPlace method provided by the Place Detection API. This method provides us a list with actually it's a buffer of likely places. Like, this method basically provides us a list that says, hey, your user is probably in one of these places. And how does it work? Again, one line, you create a pending result, and this result will contain a place likelihood buffer. And so in the onResult callback, you receive this place likelihood buffer. It's a list of possible places. And what you do, you can cycle through all these places, and here there is a very interesting, I would say this is the real treasure, the getLikelihood method. And why is that? So basically this method provides us a number, a floating value between 0 and 1.1, which is the percentage of likelihood that this is the place where the user is. So if it's, I would say, 0.9, it's 90%. So you're pretty sure that this is the actual place where the user is now. Keep in mind that this number might not sum up to 1, because the sum of all the percentage could sum up to 1, but if it's really unlikely, it's like you only get the 0.01%. So it might not sum up to 1, but it is really good because most of the time you get the actual place of the user. Also, a thing to keep in mind using the getCurrentPlace method is that this buffer of places sometimes can get huge. It contains a lot of information about these places. So it's a good practice to release after you're done with this buffer. Otherwise, you might encounter memory leaks, and you don't want to do that. No, we want to keep the app clean. Okay, let's move on to another great API provided in the Google Play services, which is analytics. We all do love stats, right? We want to understand who is using our app and how are they using it. So what if I tell you that only with not one line, one single method, you can unlock an incredible amount of information for your users. You can get gender and age demographics. You can understand the interests of these users. And then you can use this information for double-click and remarketing. For example, if you're using AdMob, this is invaluable content. And how do you do that? Well, you get the tracker, your analytics tracker, and you just add enable advertising ID collection set to true. Doing this, after a while, it takes a while because your application needs to get whitelisted, but I talk in minutes. On the Google Analytics dashboard, you will receive this kind of information. For example, you can understand the interests separated by age. For example, let's see that between 18 and 24 years old, they're interested in arts and entertainment, then arts and entertainment, TV, video online, and arts, entertainment, music, and audio. But if we take a look at the 25 to 34, this interest has moved down, and you find internet and telecom, mobile and wireless mobile phones, smartphones on top of them. So you can use this information to provide more relevant advertisement, for example, to your user. Or maybe you want to show a different type of content if they are interested in these things. It is available content. It's only one line of code. Think about that. Okay, and let's move on again. Android Wear. There has been a lot of talking about Android Wear and wearables. And the Google Play services provide all the APIs for wearables. The amount of APIs provided by the wearable API is overwhelming. However, I want to talk to you about one of the newest features of the wearable API, which is the capability API. It is really, really like looking at the future of wearables of Android Wear. And why is that? Imagine a future, a near future, where you will have an incredible amount of wearable devices, of different devices actually. And they can have different features, right? Maybe one has the GPS, another one doesn't have the GPS, or one is capable of, I don't know, doing voice transcription while the other isn't. And when you want to exchange data between these devices, you want to be sure that you are delivering to the right device. So how you do that? You use the capability API. So let's imagine we have a node requesting a particular capability and another node which has this capability. The node requesting a capability requests for capable nodes. Please give me this feature. And the node which has that capability advertise themselves. They say, hey, I have this feature, use me. And then the requesting node can send the data to the right node. Okay, but how do we advertise this capability? And you might think, okay, oh God, how do I have to check for whatever? No. It's that easy. You just create a new XML file in your, I would say, in your advertising node. You create a REST values where.xml file that contains a string array named Android Wear capabilities. And then you can add a list of strings that represents a particular capability. And it's up to you. You define this. You can call it hello world, you can call it whatever. Let's say in this case we do voice transcription. Then we have the other nodes, the nodes that want to retrieve the capable nodes. How we do that? We want to get the capable nodes. We use the capability API here, using the method getCapability. GetCapability returns inside the result a set of nodes of capable nodes. This method receives the Google API client, as always, the capability name, which is voice transcription, again, what we defined in the other. And then it receives a filter, which basically this filter, it's useful to only reach some nodes. Like in this case, we're filtering only the reachable nodes, the nodes that we can actually get, that the other node can see. If we set these to unreachable, we will just seek for the nodes that are not present in nearby. And then we return the set of nodes. Okay, so at this point, we have a set of nodes, but how can we decide what node to deliver the message? Well, we can write down a method like this, and here we can use another treasure, which is the isNearby method. How cool is that? You just say, is this thing near? Yeah, of course it is near, so we can send this message to this node. We just find the nearest one and send the message to the nearest node. Just like that. And if we don't, you just pick the last one of the list. Just that easy. Okay, and that's to the final chapter of this brief sandbox talk, which is one of my favorite actually, which is app indexing. a lot of developers has been asking, how can I have the content of my app inside the Google Now search, the Google Search app, and how can I have, I don't know, let's say for example I have a book application. How can I have my books inside the Google Search app so I can use the search to find them? Well, it all starts with deep links. You, as developers, as Android developers, will need to start to love this thing because it's going to be core for all the new Google Now and all the new app indexing stuff in the near future. What is a deep link? Well, imagine a deep link like a unique string that identifies your content. How it is composed? It has a protocol, which in this case is Android app, because we're talking Android. The package ID, which is the package of your app, and then we have the scheme plus the host path. The scheme and the host path might represent, for example, your website. If you're providing the same content on your website, you can do HTTP, in this case, example.com/myactivity. Could be a page of my website. Otherwise, you can use a custom scheme and a custom host path. However, imagine that as a URL, okay? How do we add this deep link to our activity? It's super easy. We need to add an intent filter with the name Android intent filter view, because in this case, for example, we want to view the activity when it's displayed in the Google Search app. And then we add the deep link as metadata in this data tag. You add the scheme, you add the host, and you add the path prefix, which are, as you can see on top, is the exact same thing. It's just like that. And then you add default and browsable that allows your application to be also launched when the user clicks on a link in Chrome, for example. Okay, and now we have a deep link which is connected to our Android app. Now we need to do what? We need to advertise the Google Search app. Please index my content. And how we do that? Again, it's a small treasure. It's a one-liner actually, two-liners. You need to create a view action, an action. You need to add the type, which is the type of action that will be performed when the user clicks on a particular, on the item in the search results. The name of the content you want to display in the Google Search app. So in this case, we want to show this activity, we call it My Activity. This is what is displayed. And then the app URI, and as you can see on top, it is just the deep link itself. The particular deep link that links to that content. And then we do what? We use the app indexing API using the method start, passing the Google API client, as always, and the view action. Once you've done this, this action, this activity is sent to the Google Search app, and it is indexed. And after, literally again, in a few seconds, it is available on the Google Search, through the Google Search app. For some kinds of actions, it is important to also do this when you're done advertising the content to the Google Search app, to again create the action view just like before, and add end, and use the end method. I was wondering, why should I call end? I already advertise it, but why should call end? So I asked this question to the Google Play Services team, and the answer I had, it is actually connected to what we saw yesterday during the keynote, to the context of Google Now. So basically this is saying this context has finished, and we are moving to something else. So the Google Search app and Google Now can understand that this is no longer the context. However, if you have other questions on these particular APIs, there's a bunch of people from the Google Play team right there, so you can ask them. Okay, so pretty much that's it. What's next? Please visit this link. I hope he's still up, even if they changed the website. Please visit the app indexing API website, because you can do much more than this with the app indexing API. Also because now there's all the new Google Now stuff going on, so you better check this out. So again, I'm Mario Viviani, Google Developer Expert from Italy. Thank you for listening, and if you have any kind of question, I will do my best to answer. So thank you very much.
Bravo Mario!
Any questions? Okay, I guess that was clear. Thank you, guys. Sure. Okay.